So the usual way the proof works is that usually, and I don't know for sure this will happen. I don't even know for sure it will show up, but it showed up on the study guide that just got released, the draft study guide. There's proof stuff, and so the ones that, and I will give you a list of these things before the exam. I'll probably do that this afternoon. Work through that list and make sure everything's up to date. There is the Twitch thing. But as for the proof, it's usually something like, yes, there will be a bootleg again. So usually there is something, it's usually a question that's set up exactly like this. Okay, like the one on the quiz. So it's, you're given a choice. It's usually the ones that are acceptable are usually product, quotient, and power. And you get to choose which version of the power rule you want to prove. If it shows up. And usually it's one of those options. And then we tell you to know how to prove the product rule, the quotient rule, and the power rule or something like that. Now, I don't know what it's going to look like this semester. I don't know what, I just know what the study guide draft looked like that we kind of shared. And they were on there. The other proofs that show up are the ones from last week. So prove the derivative of tangent is the 1 over cosine squared, which is secant squared. Prove the derivative of cotangent is negative cosecant. Prove that the derivative of secant and the derivative, I actually don't know them without doing the derivatives, without doing the proofs, because who cares, right? It's secant. Who cares what the derivative is? But, I can do it. I just actually have to work it out with the proof. I don't know it off the top of my head. Who cares? The Calc 2 people care because you use them a lot. But, and as I said, I could do the proof. I just have to think about it for a moment. I could do the derivative, but I'd have to prove it because I don't remember them off the top of my head. But those are the ones that usually show up. So every proof that can show up, I've already done. The proof of the chain rule has shown up before as an option, but there's always been another way to get out of it. So it will probably be on the bootleg. I don't know if it will be, because again, the bootleg now has to be approved by the body. But those are the proofs that usually show up. Are there any other questions about that? So when these proofs show up, the product rule is the easiest one to just memorize because you only really need the rabbit. And then just remember to use the definition of the derivative. And I don't think there's ever been a test without the product rule on it. The other one that's really quick is the quotient rule, and we'll do that one today. So those two, if you know those two proofs, I take that back. We did one year have a test where only the trig proof showed up. But those are I don't want to say easy, but if you understand the quotient rule and you remember the identity cosine squared plus sine squared equals 1, you can get those. So there was a year where we only did those, but every other year that we've done this, the product rule has shown up. There was one year where the quotient rule didn't show up as an option, but the quotient rule and the product rule, if you get those two in the bag, you'll have unless we just do a trig proof. But as I said, the trig proofs, all you have to remember is the definition of cosecant and 1 over sine. You just have to keep that straight, and then remember that sine squared plus cosine squared equals 1. So how do we feel about that? How do we feel about what's likely going to be on the test as far as proofs go, 1 to 5? So what is likely to show up? And as I said, I don't want you stressed about the proof. It's generally for my class, this has been free points. I have no idea when the bootleg's going to get released because that's not my. I wrote one. I sent it to her. She's going to modify the heck out of it. The study guide. It's not everything has to be approved. Let me say that again. Everything has to be approved. I will, however, let me make a note to do this. I am going to release a survey quiz about what you plan to do. So there will be a test plan survey quiz, and I will announce it. I will make an announcement for it, and I will put it online so that it's just going to ask you how you plan to study. Are there any other questions about that? Okay, so that's kind of the thing. So let's talk about, I know everybody's nervous about the test. In general, the proofs have been kind of the thing that, brings up my test scores because, people just do. I don't do every proof in the book. I only do the ones that are, I think, important and add something to the course. I don't really think the trig proofs add anything to the course, but I do them because they show up on the test sometimes. And generally my students do very well on them because if you memorize that rabbit, you can do you don't have to memorize the whole proof, just memorize the rabbit. And let's start by going over the quiz here. And I'll show you what I mean by this. So, how do I do this again? They've updated OBS on me, and things have moved around a little bit. Okay, there we go. So let's go. Ooh, my shadow's back. Oh well. I know what I can do. There we go. That got rid of the shadow. Is there going to be a retake for this quiz? Yes. Okay. So let's go back. Let's do this again. So this one, I did the product rule. What I'm going to do here is I'm going to do the product rule proof with you with the rabbit. And then I'm going to save the quotient rule proof with the rabbit for 5 o'clock. And then I will do the quotient rule proof without the rabbit using the other rules for you real fast. And this is actually one that's kind of easy, that you could get away with kind of slickly. If you understand the rules really well, the quotient rule proof is actually the easiest because you can use the other rules. And there are actually 3 proofs where you use the other rules. It's kind of there's a lot to do there. All right, so what we're going to do is we're going to use the H definition of the derivative. Expand, add the rabbit to the top, group factor, and apply the limit laws. And then f of x plus h goes to f of x, since f is continuous at x. There's the rabbit. Now, the rabbit is just something you have to memorize. It is literally something that some mathematician pulls out of his hat or out of his butt, as it may be. Okay? The fact that 0 equals negative f of x plus h times g of x plus f of x plus h times g of x. So a rabbit is either a 1 that you multiply or a 0 that you add. All right? So I'll just write that down. A rabbit is something that equals 1 that you multiply and something that equals 0 that you add. Because I can always multiply by 1 and add by 0. All right? Is everyone on board with that? I don't want to use the poll because I've already got it set up. Now, do you have to write this? No, not on the test. On the quiz, yes. On the quiz, absolutely your strategy had to be written. I will take points off for not doing it on the quiz. On the test, you don't. But look how many points I have now secured. I have now secured half the points. Okay? I got what I want to do. I have the strategy. I'm going to use the H definition. I'm going to add the rabbit to the top, apply the limit laws. Hey, I already did the continuity bit, and I stated what the rabbit was. And that rabbit is going to be points as well. Right? Now, the rubric is going to say, you applied, it's going to be line by line with points. But, and I cannot stress this enough, but if you write down your strategy ahead of time, you lock up a bunch of points, because things like mentioning the rabbit, mentioning these things. And again, I'm the only one who calls it a rabbit. Most of the other instructors do magic tricks or, something like that. I think there's another one using rabbits now because she liked it. But the proof has a rabbit either way, right? I'm the only one who just says, oh, we call it a rabbit, Well, again, there's another instructor that's doing it now, I think. But that's, it's a magic trick, right? It's something I'm conjuring kind of out of thin air. It's a 1 or a 0 that I'm, multiplying it by 1, I can always do. Add by 0, I can always do. So the chain rule has a rabbit where you multiply, g of x minus g of t over g of x minus g of t, which is 1. And this one has an add, and the quotient rule has an add if you want to do it with the rabbit. Okay. So let's go on. Let's talk about this. I'm determined that rabbit will make it in a textbook at some point in the future. I think this is the way to teach it. Actually just calling it a rabbit instead of just bearing, because that's kind of the lead of the whole proof, right? All right, so let's do this. So what I'm going to do is I'm going to do f times g prime of x. Now, I'm going to write over in the corner here, I'm going to write the actual, you don't have to do this, but I'm going to write what the definition of the limit is, right? So I'm going to write the limit, I'm going to write u prime of x equals u of x plus h minus u of x all over h with the limit as h goes to 0. I'm going to write it using some other symbol. I don't care if it's u. I don't care if it's alpha. But I'm going to use something other than f, because f is about to show up in this proof. The other way to do it is just use u and v as the things. But I'm just going to kind of write that over to the side. And it should be noted that this is not a value. This is a function. If that confuses you, don't worry about it. You don't need to do it. I'm just writing it off to the side. So I'm going to do the limit. Now my u here is fg of x plus h minus fg of x all over h. Okay, that's the definition of the limit. Now, I'm going to expand the top. Now I add my rabbit. And you don't have to do that. As a matter of fact, what I'm going to do is say this. Just kidding. And I'm going to say rabbit. And I'm going to do limit as h goes to 0, f of x plus h, g of x plus h, minus f of x plus h, g of x, plus f of x plus h, g of x, minus f of x times g of x. Oops. I love that about OneNote, that you can erase a whole line. And that's kind of the key. So now I'm going to break this up, and I'm just going to do, now, that's the key step. I can get away with shortcutting because I wrote a strategy. I can now get away with doing a whole bunch of steps at once. Okay? So now I'm going to do the limit as h goes to 0, and I am going to group. I am going to group and factor and apply the product law all in one step. And I can get away with this because I wrote a strategy. This will be some law, actually. And I can get away with that because I wrote a strategy. So the fact that I wrote a strategy gets me the communication points that writing the intermediate steps would have gotten me. So that was the group, factor, and sum law steps all at once. Now, I'm going to apply the product law to the first side. I'm going to get the limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x all over h plus g of x times the limit as h goes to 0 f of x plus h minus f of x all over h. And that equals f of x times g prime of x plus g of x f prime of x. Now, I got away with this jump without mentioning this thing. Remember when I did the proof? Remember what? Now, someone's asking me, can I do that? And I will show where that came from. So I will do it. But remember when I did the proof on the video? There were all of these steps in between here that I've now skipped. I haven't mentioned continuity here. I haven't mentioned that these things are the definitions that I'm looking for. I haven't done any of that. And the reason I can get away with that is because I wrote the strategy. So sure, I have to write 4 lines here. But it just saved me 4 lines of symbol gibberish. Okay, the symbol jump, if you want them, are these. Let me see if I can copy and paste here, because that will be much faster if I can. Oh, let's see. There we go, lasso select. I want all of you. I don't want you. I don't want you. I want you. All right. So I'm going to write the jumps over here. Let's see. So this piece here, and this piece here becomes that piece there. And then this piece here and that piece there will become this piece in front. All over H. Okay, then that will equal, now I split it up using a common denominator. So recall A plus B over H equals A over H plus B over H. There's that piece, right? And then I did a sum law here. Then I did a product law to pull this one out. This one came out from a constant multiple law. This one came out by the product law. All right. Then this one right here, I'd write a little note. Since f is differentiable at x, f is continuous at x, so the limit as h goes to 0, f of x plus h equals, by direct substitution, f of x plus 0, which equals f of x. This right here is g prime of x. This right here is f prime of x. And then I get my conclusion. Okay. All right, people have been asking me questions and I've been fuddling with this. So how come there are 3 f of x plus h lines? Maybe I messed it up. Oh, no. Okay, so the rabbit line has 3 f of x plus h terms because that's what the rabbit is. The rabbit is negative f of x plus h times g of x plus f of x plus h g of x. So when I go to the next one, I wind up with 2 terms because I factored this one. So I factored the f of x plus h out here, and I got that. And here, I factored out the g of x, so I got that. Okay? Oh, okay. So, yeah, then you said you saw why. Okay. So how do we feel about this 1 to 5? Hold on. Why is it still going? There it is. There we go. Yeah. So if you, and again, if you do a strategy, if you don't do a strategy, you actually need to show all of these steps. Okay? You have to explain the continuity bit. You have to explain where you got these. You have to do the little arrows. right? But if you do a strategy, you can get away with jumps. So in one sense, the strategy saves you from forgetting a step. The other thing it does is it means that you have to write less. So even though you have to write a strategy, you end up writing less because you can skip steps. Okay. So again, and it's up to you how to do it. Now, on the quiz, you had to write a strategy. But on the test, if you wind up not wanting to write the strategy, just remember you got to show all those steps. And so the usual way that students try to go about this is they try to memorize every line of the proof. And that's not the way to do this. The way to do this is not to memorize the entire proof. The way to do this is to memorize a strategy. And the strategy doesn't have to be line by line. The only piece that you really have to have perfect is that rabbit. Right? So if you memorize the rabbit, the rest of it just kind of flows. As long as you know the definition of the derivative of kind of how to put it together. But you don't have to memorize all the lines, right? You just have to memorize that rabbit. All right. As I said, I'm going to do the quotient rule at 5 o'clock for that proof. But let me do this other proof here. All right. So there's a couple ways to do the quotient rule proof. But this one right here, I'm rather fond of. It just uses the other rules. So what I'm going to do, what I want to show is that the derivative of u over v equals the derivative of u with respect to x times v times the derivative of v with respect to x times u. And I have these rules here, right? This is the reciprocal rule. And this is just the derivative of 1 over x. Right? Those I get for free. Those I get to bring in. So my strategy is going to be to write as u times 1 over v and apply the product rule, reciprocal rule, and chain rule. And the fact, actually, I'm not about to apply the chain rule, just the product rule and the reciprocal rule. And the fact that that is, and then I'm going to take a common denominator. So that gives me the derivative of u over v equals the derivative of u times 1 over v. And then I apply the product rule to that bit. And my want to show is incorrect, isn't it? Don't I feel like an idiot? There we go. Let's fix that. I did this a little quickly. And then I get these things just kind of pop off. Okay. How do we feel about that proof 1 to 5? So, quotient rule. And there's another way to do this. If you have access to the power rule, which you do, there's an even slicker way to do this. So let me do another proof. I want to show the same thing, that d over dx of u over v equals u prime v minus uv prime all over v squared. My strategy is going to be u over v equals u times v to the negative 1. So apply quotient, not apply quotient, apply product and chain rule. Product, there should be a power right here. Product power and chain rule. Okay? And here's how it works. D over dx of u over v equals d over dx of u times v to the negative 1 equals, and I do a product, u, the derivative of u times the second plus the first times the derivative of the second. Okay? All right, and then that equals, well, there's the u prime I want. V negative 1 becomes the under v plus u. Now I need a chain because the inside here is v. So now I need a chain. I do d over dv of v to the negative 1 times d over dx of the inside, which is v. So the outside is the v to the negative, is the to the negative 1, and the inside is the v. Now this becomes the derivative of this. I use the power rule, negative 1 v to the negative 2 times, and then this is the v prime I want. And that equals u prime over v plus, sorry, minus, because I've got a minus here, that negative comes out, minus u, that v squared goes on the bottom, so v prime over v squared. So the negative 1 came out, and this moved to the bottom. And then I just take a common denominator, and I get u prime v over v squared minus u v prime over v squared equals u prime v minus u v prime all over v squared. So that's the other way to do it. Okay. Using chain. Stop, start. So again, it depends what you like. There's actually another way to prove it, but I won't do that proof because it's kind of a Calc 2-ish kind of proof. It's kind of slick in that way. But there is another way to prove it that some people like. Any other questions about this? And all of these are legal. And then the log proofs are illegal, but if you did them, you'd get partial credit. So if you don't remember anything at the end of the day, you can use a log proof, but you won't get full points. Okay, I'm using up all the time going over the quiz, aren't I? Oh well. Okay. Okay, there is a u right here. And that's that negative x. So I'm going to wind up with 1 times 2 to the negative x plus x times the derivative here, d over du, 2 to the u, times d over dx of u equals 2 to the negative x plus x times derivative of the outside is the log of 2 times 2 to the u times the derivative with respect to x of negative x. And that's going to equal, let's carry all my baggage here without making a mistake. -1. All right. How do we feel about that one? Let's see. This is 2a. 1 to 5. So there's a lot of parts to that one. It's a product and a chain. Right, so we have the journey of x over here. We've got two x's. X goes in 2 places. This x over here becomes a negative x, which becomes a 2 to the negative x, and then these two things get crammed together as a product. So when I work backwards, I'm going to use the product rule, and then I'm going to use the chain rule. Okay. All right, here's another ugly one. So I've got ds over dt equals the derivative with respect to t of t to the 3/4 cosine of t. Actually, this one's not bad at all. This is just a product rule. Product. So I'm going to get d over dt of t to the 3/4 times cosine of t plus d over dt. Plus t to the 3/4 d over dt cosine of t. That was supposed to be an open paren. Equals, okay, so this is going to be a power rule. So this is going to be 3/4 t to the 3/4 minus 1 cosine of t plus t to the 3/4 times negative sine of t. And then my final answer is going to be 3/4. This is going to be 4 over 4. So this is going to be negative 1/4 cosine of t. I'm going to pull the negative out just because I feel like it. Not required. And that's it. So 1 to 5, how do we feel about that one? Okay. This last one's a bit trickier. I need to do implicit differentiation on it. I need to do a log differentiation on it. So what I'm going to have here is I'm going to have to create a y. Okay. Then I'm going to have to take the natural log of both sides. Now you can either make this ln of x squared and do a chain rule, or you can do a product rule. It's entirely up to you. I'll do the, I think I did, I'll do one on one video and one on the other. How do I know I have to create a y? I know I have to create a y because I'm going to have algebra going on over here. Okay, that's how I know I need to create a y. I need to create a y because I want to take the log of both sides. And the steps for all of these are, now I actually can get away not creating the y, but it's much more complicated. What I would do is I'd do e to the ln of, and then do the derivative of e to the ln of. And there are a couple videos on YouTube showing you how to do that. I suggest against it. It's easier to create a y than deal with a double chain. If you like it though, that's up to you. You can do it by doing e to the ln of. But it's easier to deal with, to create a y than deal with a double chain. And there are places where you can't really use that trick. So this is a much more general trick that allows you to do more. Because this trick here allows you also to do the derivatives of inverses. And we're going to see that again when we do the inverses of sine and cosine. So when we do arcsine and arccosine and arctangent and all those things, you're going to see this trick again. So this let y equal something is a good trick. All right, now I've manipulated this so that it's something I can take the derivative of both sides of. So now I'm going to do the derivative of both sides with respect to x. All right, this right here is going to become 1 over y dy over dx equals. Now this derivative here is going to have a chain. This is my u. So I'm going to get d over du of u squared times d over dx of u. And that right there is going to equal 2u times d over dx of u which equals 2 ln of x times the derivative of ln of x, which is 1 over x. Now, I made this y, so I need to multiply y over to the other side, and I get dy over dx equals y times 2 ln of x times 1 over x. And I made y, so I need to give y back. So since I made y, I'm going to uncreate y here, and I'm going to get x ln of x times 2 ln of x times 1 over x. Okay, and that's going to be my answer. All right, that one's hard. And that one's not even simple. It's complicated too. Right? That's not simple but hard. That's complicated and hard. So 1 to 5, how do we feel about this? Okay. All right. Okay, so let's look at the problem set. We don't have a lot of time left, and I want to let you work on the problem set. Sorry I'm taking up all the time to go over the quiz, but I thought it was important. As I said, I will go over this proof here at the 5 p.m., and I will post that to YouTube. By the way, you've noted, or you can watch it on Twitch. By the way, you've noticed that I've finally caught up on YouTube with what needs to be going on. Are there any more questions? So the answer to that question is, how do I know I create a y? I create a y when I want to do algebra tricks. How did I get the ln of 2? The ln of 2 came from the exponent rule. Okay. All right. Okay. All right, so I'm going to stop streaming.